Hello and I welcome you to my classes on concrete technology, and today we are mainly discussing about a numerical example of mixed proportioning, and it is example of without admixtures. Means here we are not using any fly ash as a replacement material of cement. Myself Vishwanath Avati, and here mainly in this we are not solving all the steps, only the main initial 5 steps we are solving. In that, first step is target strength for mixed proportioning, approximate air content, selection of water cement ratio, selection of water content, and last one is calculation of cement content. And remaining steps where you can see in the next video from step 6 to steps 10, right? So now we'll go through example, right? Here an example is illustrating the mixed proportioning for concrete of M40 grade. Here it is M40 grade. So now they will give data. So initial data they will give of proportioning, and here you can see the data of given data. Here grade is M40, type of cement is PCC, maximum nominal size of aggregate, right? Maximum nominal size of aggregate is 20 mm, and exposure condition. Exposure condition, you can see here it is exposure condition is severe, and for reinforced concrete, here it is reinforced concrete. Reinforced concrete. Then workability is 75 mm. Method of concrete placing, right? Non-pumpable. Degree of site control, good. Type of aggregate, crushed angular aggregate. Maximum cement content, not included fly ash, 450 kg per meter cube. Chemical admixtures, superplasticizers, normal superplasticizers, right? But in this, whatever we are in this video, we are mainly focusing these initial data. One is grade of concrete, type of cement, and exposure condition, workability, and remaining data we will see in the next videos, right? So very important. Just remember, grade is M40, cement is PCC, and nominal size of aggregate 20 mm, exposure condition severe, and reinforced concrete, and workability is 75 mm, right? So next data they will give related to test data of material. So in this you can see cement used is PCC, right? Then specific gravity of cement 2.88, chemical admixtures, superplasticizer, specific gravity of coarse aggregate 2.74, fine aggregate 2.65, chemical admixtures 1.145, water absorption, coarse aggregate 0.5%, fine aggregate 1%, moisture content of aggregate, right? So here it is coarse aggregate nil, fine aggregate nil, means it is a dry condition. Next, even you can see next test data is sieve analysis. In the sieve analysis, coarse aggregate conforming to the table 7 of IS-383, and fine aggregate conforming of grading zone 2 of table 9 of IS-383, right? We will see how data are very important with the steps, right? So as I told, now we are solving only 5 steps, right? So now we'll start with the step 1. Step 1, target strength of mixed proportioning, right? What kind of target we are achieving. So already M40 is already mentioned, right? M means what? Mix, and 40 means what? It is a characteristic strength of concrete, right? So but here target strength of mixed proportioning, why? Because we have to maintain factor of safety, right? So but to calculate target strength of mixed proportioning, we have to use a formula according to code book. So here according to the code book, the formula is F dash CK. So F dash CK means what? Target average compressive strength at 28 days, right? It is what we have to calculate. That equal to FCK plus 1.65 S. 1.65. So here we have to understand what we mean by FCK. So FCK is characteristic compressive strength at 28 days, right? So that is they already given M40. So then it is 40 Newton per mm square, right? Because M40 is already given, that is characteristic compressive strength at 28 days. But target strength is F dash CK. And here also one more unknown is there, S. So S is standard deviation. right? So we'll get to know how to get that data, right, from the tables. And even and we have one more formula, that is f dash ck equal to fck plus x. So right here unknown are f dash ck, right, and even s and x, right? So here to know the values of standard deviation and factor based on grade of concrete, right? So here we are selecting those data from the tables. So from table 2 we'll get a value of standard deviation, S value, that is 5 Newton per mm square, and I'll tell you how to get the values of standard deviation. And even from the table 1 X value is 6.5. See now table 2. So here in the code book they have given a table 2. Even you will get with your, if you refer the code book, then you will get a table 2. So here it is assumed standard deviation, assumed standard deviation. But here we have a like no M40 grade of concrete. For M40 grade of concrete we have a value of 5, right? So here you can see assumed standard deviation, and for assumed standard deviation for M40 we have 5. That's what they taken. S is equal to 5 Newton per mm square. So next table 1. So here you can see the table 1 value of x. So here they are given serial numbers, grade of concrete, then value of x. So far we have a M40 grade. So for M40 grade it is value of x is 6.5, right? So this kind of table you will get from the code book, and code book will be given to you to solve the problems, right? So then we'll go for next step. Next step means what? To calculate, right? Therefore target strength using both equation, that is first if you use the first equation f dash ck equal to fck plus 1.65, yes. So as I told, from table 2 we got a value of s is 5, and if you substitute the value of 5, then you will get a strength of 48.25 Newton per mm square, right? So we will see one more formula is there, f dash ck equal to fck plus x, right? So x value we got from table 1, and if you substitute the value of x 6.5, then you will get a strength of target strength of 46.5. But here we have to take higher value, right? I already mentioned the higher value is to be adopted. Therefore the target strength will be 48.25 Newton per mm square, right? So here it is, higher value is 48.25 and lower value is 46.5. That's what we are adopting. Target strength of mixed proportioning is 48.25, right? One we had already calculated. Note down the value, it will help for next solving the problems. So we'll go for next step. So step 2 is approximate air content. Approximate air content. So now how to calculate the approximate air content? So here as per the code book we have to refer table 3. We have to refer table 3. The approximate amount of entrapped air to be expected in a normal non-air entertaining concrete is 1% for 20 mm nominal maximum size of aggregate. So here aggregate is given 20 mm, and if you refer the table 3, you can see here table 3, and here in the table 3 approximate air content you can calculate, right? You can find out, and here first column is serial number, second column is nominal maximum size of aggregate, right? For us it is 20 mm, right? Nominal size of aggregate is 20 mm, and entrapped air as percentage of volume of concrete, column 3. So we'll get 1%. Here it is what? Percentage. They already mentioned here it is percentage. So then 1% is for 20 mm of normal size of aggregate. So that's what. Therefore approximate air content is 1%. Correct. And we'll go for next step. Next step is selection of water cement ratio. So here we have to select the water cement ratio, right? So now here from figure 1, right, from figure 1 in code book, the free water cement ratio required for the target strength of 48.25. This value we got from calculation, right? So first step 48.25, and for 48.25 we have to get to know what is a cement water cement ratio. That is, from the figure it got 0.36. From the figure they got 0.36 for OPC 43 grade curve, but even we are assuming the same for PPC, right? The strength of corresponding to OPC 43 grade curve is assumed for the trial, right? So here I'll tell you how they got a 0.36 as a water cement ratio for 48.25 Newton per mm square, right? So now we'll see the figure 1, and this figure is there in the code book, right? Here you can see curve 1, 2, 3 curves are there, right? If you read the note, right, curve 2, so here it is curve 2, right, for expected 28 days compressive strength of 43 and less than 53 Newton per mm square, right? Curve 2 is for less than 53 Newton per mm square, but our strength is 48.25. That's what we are referring the curve 2, right? So if you see the curve 2, we got 48.25 approximately, and that arrow mark is not exact, but just you can assume it is 48.25. For 48.25 we are getting approximately 0.36. It is free water cement ratio. X-axis is free water cement ratio, that you can see 0.36 for 48.25 compressive strength. So next, this is lower than maximum value of 0.45 prescribed for severe exposure for reinforced concrete as per table 5 of IS-456. So here they are comparing with the maximum value which is given in table 5 of IS-456. So here also I can show you a table 5 of IS-456. You can see here IS-456 table 5. So in the table 5, right, here different conditions they are given, that we should not worry about all the conditions. Now we have to go for severe condition. Why? Because in the question they given the structure is exposed to severe condition. So here we have to select the severe condition, and for that we have to go for reinforced concrete. Why? Because they mentioned already it is a reinforced concrete. So then we have to go for maximum free water cement ratio. We have to focus on this only. Even we will refer these data, but according to the requirement we'll study. But now you focus on only this reinforced concrete and maximum free water cement ratio, right? So here it is how much? 0.45, right? So that's what they are telling, that it is lesser than 0.45, lesser than 0.45. That's what it is. Okay, lesser than. Why? Because we already studied, if it is water cement ratio is less, then we are getting good strength. That's what 0.36 is better than 0.45. That's okay. So right, so here it is how much is the water cement ratio for our future reference? 0.36, right? Okay. So next we will go for step 4. So in the step 4, selection of water content. So here it is selection of water content, how much water is required for preparation of concrete. So here also we have a procedure according to the code book. Now from table 4, right, from table 4, the water content 186 kg for 50 mm slump for 20 mm aggregate. So now we'll go for table 4 first, and then we can understand. So here it is a table 4, water content per cubic meter of concrete for nominal size of aggregate, right? So here it is what? Serial number, first column is nominal maximum size of aggregate, right? So here it is size of aggregate they given, and what is our given data size? 20 mm. Next is water content, right? Water content they given column 3. So here for 20 mm of aggregate we can get approximately 186, but it is only for 50 mm of slump, correct? But for us they given 75 mm of slump. That's what there is a note. The note is 3% increase for every 25 mm slump. 3% increase for every 25 mm slump over and above 50 mm of slump. So here it is what? For 50 mm we can take water content of 186 kg. But here it is for us it is 75 mm. Even you may get 125 mm according to, right? But according to our given data in this problem we have a 75. 75 means what? Another 25 extra is there, right? So that's what, if you are increasing 25 extra, then we have to take 3% more than whatever given data. That's what you can understand easily why 3%, how to take the 3%. If you see now, estimated water content for 75 mm slump, right? For 50 mm slump, how much we got? 186 from table, right? So then we have to take another 3% extra, 3% extra of 186 kg, right, water content. And if you consider that, and total we will get, if you take 3% extra, then we will get 191.58 kg, right? So next, a superplasticizer is used, right? We know what is the characteristics of superplasticizers. They are the water reducers, right? In the given data, they told you we are using superplasticizer of normal superplasticizers, right? The water content may be reduced based on trial data. So here it is, based on trial data, the water content reduction of 23%. From the trial, even you have to consider from the trial only, and from the trial the reduction of 23%, right, is considered while using superplasticizers at the rate 1% by weight of cement, right? So here they are telling that approximately 23% of water content we can reduce it by using superplasticizers. So that's what to calculate. Hence water content is equal to 191.58. So how we got 191.58? From this calculation, right? So but we have to take only of 77%. Why 77%? Because in 100% we reduced 23% by using superplasticizers, and remaining is how much? 77%. If you take in fraction, it will come 0.77. So that's what we are considering. Out of 191.58 kg, we are taking only 77%. That's what the total water content required is 147.52 kg, approximately equal to 148 kg. So how much you got the water content for future reference? 148 kg. Yes, next last step in this video, and remaining steps will be in the next videos, right? So calculation of cement content. So next is cement content calculation. So here water cement ratio is how much? 0.36. So how we got? From the calculation we got 0.36. Why? Because we had got compressive, like no, targeted strength of 48.25 in step 1, and from the figure we got the water cement ratio of 0.36, which is lesser than 0.45. So we adopted 0.36 as a cement water cement ratio. So then we have to calculate the cement content. So here we have a ratio of water by cement. So just for calculation of cement, then we are sending we are sending cement to the left side, and we are taking 0.36 for right side. So then we can calculate easily, right? Cement content is equal to water content divided by ratio. So 148 is water content. So how we got 148? From the calculation of step 4. So from the step 4 we got 148 as a water content. So right. So that water content we got 148 from step 4, then divided by 0.36. Why? Because it is a water cement ratio. Then if you calculate from this, we will get calculation cement content is required is 412 kg per meter cube. So from table 5 of IS-456, again we are using a table of IS-456, minimum content for severe exposure condition. So from table IS-456, right? So one table we already used that, but I focused only for water cement ratio. In that table also they given for severe condition how much minimum content cement was to use. So in that they mentioned for severe condition 320 kg per meter cube we have to use minimum, but we are going more than minimum, right? So we got from calculation it is 412, but according to the code book it is 320 kg per meter cube minimum. So no problem. If you see the code book, right? So in the code book I told many datas are there, but we'll focus based on our requirement, right? So now I told it is what reinforced concrete, right? So in the reinforced concrete, first is minimum cement content. So then for which we have to see for severe condition. For severe condition, what is the minimum cement content? 320, right? So if it is less than that, then we have to take 320 as a minimum. For example, from calculation you got 300 kg per meter cube. then we have to take minimum of 320 kg per meter cube, right? So 412 kg per meter cube is greater than 320 kg per meter cube, hence okay, right? So for next videos, for next steps, see the next video, right? So just I'll summarize. In this video, just we seen the problem of without admixtures, and they have given some datas, right, of and even test data of material they have given, right? And first we have to calculate the target strength of the concrete. That we have a two equations. From two equations we have to solve, and for that they require the data of standard deviation and x value. From table 1 we will get x value, and from table 2 we will get x standard deviation values, and if you substitute those values in that equation we will get target strength, right? So in this problem we got the target strength of, right, f dash ck is 48.25 Newton per mm square, right? So then we got a minimum air content. That minimum air content for 20 mm aggregate is 1%. Then step 3 we calculated, in step 3 we calculated the right now cement water cement ratio, and for water cement ratio we referred for figure 1, and in that figure we have three curves, curve 1, curve 2 and curve 3, and for our data it is less than 53 Newton per meter cube. That's what we referred the curve 2. From the curve 2 of corresponding strength 48.25 Newton per mm square, we got water cement ratio of 0.36, right? So then step 4 is the calculation of water content. For water content we got approximately 148. So we see how we got 148. Why? Because we refer the table, and by using a even considering the super plasticizers, we got approximately 148 kg of water, right? So then we use the same for calculation of cement content, and here we got a cement content of 412, right? And next steps, see the next videos, right? Thank you so much watching for this video.